I was looking at the math that Answers in Genesis presented to show all the animals could fit on the ark. First, they start out with 3 different values for the length of a cubit. 300 cubits is 460 feet, so a cubit is 18.4 inches. 50 cubits is 75 feet, so a cubit is 18 inches. 30 cubits is 44 feet, so a cubit is 17.6 inches. Then they prove they can't do grade school math by multiplying 460 by 75 by 44 and getting 1,540,000. The correct answer is 1,518,000 cubic feet. Guess Ken wanted to cheat and throw in an extra 22,000 cubic feet. Most sources say a cubit is 18 inches. That gives us 450 feet by 75 feet by 45 feet, which is 1,518,750 cubic feet. More than Ken's dimensions give, but less than he says they give. AIG says this volume is equal to 522 railroad boxcars. That would give the volume of a railroad boxcar equal to 1,540,000 divided by 522, or 2950 cubic feet. I looked it up. Railroad boxcars range from 2,720 cubic feet to 2,975 cubic feet, so I will accept his value of 2,950 cubic feet. But since his 1,540,000 number was a lie, the number of boxcars would be 1,518,750 cubic feet divided by 2,950 cubic feet, which equals 514.83 boxcars. But that's how many boxcars would fit in a box the size of the ark. But boats are not shaped like boxes. Boats are shaped like half of an ellipse stretched out a length. The volume of a shape like that is pi over 4 times width times length times height. But he used width times length times height, which would be the volume of a box. So to get a boat-shaped volume, we need to multiply it by pi over 4, approximately 0.7854. So our more accurate volume is 1,518,750 cubic feet times 0.7854, which equals 1,192,826 cubic feet, which would be equivalent to 404.34 boxcars. Now that we have a more realistic volume, let's look at getting a more reasonable amount of that volume that could be used for storage space. Warehouses, on average, use 70% of their space for storage and 30% of their space for access to storage. So we take the 1,192,826 cubic feet times 70% gives us 834,978 cubic feet, or 283 boxcars, which is approximately 54.2% of the number of boxcars Ken said we had to work with. But now we have to get from boxcars to animals and food. AIG's site says a boxcar can hold 240 sheep and claims that the average animal is that size. So if Noah didn't have to store food for the animals, the maximum number of animals he could have would be 283 boxcars times 240 animals per boxcar, which equals 67,920 animals, or 33,960 pairs of animals. But since Noah would have to store food, that would reduce his space for animals. So how much space does a year's supply of food for a sheep-sized animal take up? Let's look at elephants. They eat a minimum of 200 pounds of food a day. Yes, elephants are much bigger than sheep, but I'm going to account for that. Grass silage takes up 200 cubic feet per ton, so over a year you'd have 200 pounds per day times 365 days divided by 2,000 pounds per ton times 200 cubic feet per ton, or 7,300 cubic feet. If the average animal is the size of a sheep and the average elephant is 40 times heavier than a sheep, then an estimate for the average animal's food storage is 7,300 cubic feet divided by 40, which equals 182.5 cubic feet. According to Ken, the sheep itself takes up 1/240th of a boxcar, or 12.3 cubic feet, making the amount of food it needs in a year take up 182.5 cubic feet for the food, divided by 12.3 cubic feet for the sheep, equals 14.8 times as much space as the animal does. Now, premium beef has a density of 97 pounds per cubic foot. A cubic foot of it would feed a lion for about 2 days. Sheep are about half the size of a lion, so I'll say our sheep-sized meat eaters use a quarter of a cubic foot of food storage per day, or 0.25 is 1 quarter times 365 days equals 91 cubic feet of food storage in the year. And if we compare that with the size of the animal as well, we'd have 91 cubic feet divided by 12.3 cubic feet would be taking up 7.4 times as much space as the animal does. So we have between 7.4 and 14.8 times as much space needed for the food as there is needed for the animals themselves. Most animals are not meat eaters, so the true value would be closer to the 14.8. But I'll be generous and say it's closer to the middle. I'll call it 11. So those 33,960 pairs, that was the maximum without food, gets reduced to 33,960 divided by 12, and it's 12 because 11 times for the food and 1 time for the animal, which equals 2,830 pairs plus their food. I haven't even considered space for clean water, and they would need it. The one window they would be allowed to have would be too busy with a constant flow of urine and manure going out to allow for water to come in. And now conclusion. There is nothing plausible about the flood story. Millions of species evolving from at most 1,000 couples, much less than the 28-30 pairs would get off the boat because animals living under those cramped conditions for a year would lead to many of them dying. And the ones that did get off the boat, many of those animal couples' descendants would go extinct because the genetic base of two individuals is not likely to survive. Yes, Adam and Eve are bullshit too. And this doesn't even take into account the fact that all the plants would have died, so the plant eaters would have nothing to eat, the meat eaters would eat them, and then they would die of starvation. Creationist math is an oxymoron.